All right, welcome back. Today, we are diving into one of the biggest challenges in AI, finding that perfect balance. We're going to talk about how to tune a classification tree, basically turning it from a machine that just guesses into a smart, reliable partner. So let's get into it. Okay, so picture this. You've built a model, it passes all the training tests with flying colors, looks absolutely brilliant on paper, but then you set it loose on some new real-world data, and it just completely falls flat. It starts making really dumb mistakes. So why does that happen? That's the exact problem we are going to solve today. Well, the answer lies in what I like to call the Goldilocks problem. See, on one hand, you've got overfitting. This is where your model has pretty much just memorized the training data. Every single little detail and weird quirk, it's way too complex. And on the other hand, you have underfitting. Here, the model is so simple that it's completely missed the real patterns. Our job, it's to find the model that is just right. So how do we actually find that sweet spot? Well, think of it like this. Our model has a control panel. And on that panel, we've got 5 key levers, 5 parameters that we can tweak to steer our model away from those extremes and right toward that perfect balance. And here they are, the 5 main controls on our panel. We're going to walk through every single one, talk about what it does, and I'll give you a solid rule of thumb to get started. This is basically your roadmap to building a much smarter model. First one up is induce binary tree. Think of your model as making decisions by asking a series of questions. Well, this setting forces every single one of those questions to have only 2 possible answers, like a simple yes or no. This creates just 2 branches at every step. It keeps things really simple, clean, and honestly, a lot easier to understand. And the advice here is just refreshingly simple. For the vast majority of datasets, just turning on the binary tree setting can actually boost your accuracy. And why is that? Because it forces simpler decisions, which is your best first line of defense against making things too complicated and overfitting. Okay, next up, the minimum number of instances in the leaves. Now, a leaf is just a final prediction, the end of the road. This parameter basically tells the model to stop creating super specific rules that only apply to 1 or 2 examples. That's the very definition of overfitting, confusing random noise for a real pattern. This forces the model to only make predictions that are based on meaningful groups of data. So, where should you start? What's a good number? Well, if you're working with a decent-sized dataset, let's say 500 records or more, setting this value somewhere between 10 and 20 is a fantastic starting point. This just makes sure that every final conclusion your model comes to is backed up by a solid chunk of evidence, not just some random outlier. Now, I know what you're thinking. This one sounds a lot like the last one, but the difference is actually really important. The last setting was all about the final destination, the leaf. This one is about the journey. It tells the model, hey, don't even bother splitting this group if it's already pretty small. So, if your minimum leaf size is 10, but you set this minimum split size to, say, 25, any group with 20 data points just stops right there. It can't be split again, so it automatically becomes a leaf. It's a really great way to keep your tree from getting way too deep. Yeah, a really great rule of thumb here is to set this as a percentage of your total data. So for instance, if you've got 1,000 records, setting this to 5% means you'd start with a value of 50. This stops the tray from going down these long, winding rabbit holes based on tiny, tiny slivers of data, which keeps the whole thing much simpler and way less likely to overfit. This next control is probably the most direct way you can manage your model's complexity. The depth is just the longest chain of questions from the very start of the tree to any final answer. So, a deeper tree means a more complex model, and a shallower tree means a simpler one. It's as simple as that. So, what's a good depth to aim for? Well, for smaller datasets, maybe anything under 100 records or so, keeping the depth between 3 and 5 levels is a super powerful way to fight overfitting. It physically stops the model from asking too many questions and getting lost in all the little details. It's kind of like telling your model, hey, just ask the 3 to 5 most important questions and then stop. That way, it doesn't go chasing after patterns that aren't even really there. And our final lever, think of it as a purity check. So imagine you get to a point in the tree where, say, 95% of the data is already pointing to the same answer. This parameter tells the model, you know what, that's good enough. Just stop here. It keeps the model from wasting all its energy trying to perfectly classify every single last data point, which, as you can guess, is a classic way to overfit. So typically, you're going to set this pretty high, somewhere between 90 and 100%. But here's a really important pro tip. If your data is what we call imbalanced, like if you have 950 no answers and only 50 yes answers, Setting this percentage a little lower can actually help the model generalize better. It forces it to look a little harder for those patterns that identify that much rarer yes group. Okay, so we have our 5 controls. We know what they do, but how do we use them all together? I mean, you don't just set them once and forget it. There's a strategy to this, a master plan for finding that perfect combination. And the heart of that whole strategy is this one concept, cross-validation. This is without a doubt the single most important technique for tuning your model. It's how you really test your settings on data the model has never seen before. Imagine splitting your data into, say, 5 chunks. You train on 4 of them and test on the 5th one. Then you do it again, but with a different chunk held out for testing. You repeat that until every chunk has had a turn. This gives you a much more honest, reliable score of how your model will actually perform in the real world. It's really the ultimate reality check. So your whole tuning strategy really boils down to this simple 4-step plan. First, always start with cross-validation. Second, use all those parameters we just talked about to actively fight against overfitting. Third, make sure you tailor your settings to the size of your dataset. One size does not fit all. And fourth, pay extra special attention if your data is imbalanced. You know, when it comes down to it, this all comes back to our main theme. Building a great model isn't just about throwing data at a machine. It's an act of finding the right balance. It's really part science and part art. And this quote from our source material just absolutely nails it. Mastering these settings gives you direct control over 2 things, your model's complexity and its ability to generalize, which is just a fancy way of saying its ability to make smart predictions on new data it's never seen. And that's the whole point. So let's just recap the big stuff. Number 1, tuning is all about that balancing act. Number 2, those rules of thumb we went over, they are your best possible starting point. Number 3, always tweak your settings based on your specific data. And finally, remember this, cross-validation isn't just a nice to have, it is your most critical tool for success. We've basically just put the control panel right in your hands. You now have the knowledge to tune a model, to find that perfect, delicate balance between just memorizing the past and actually understanding the future. So, the only question left is, what will you build?